Yeah, hi. So we're here today at a brownfield project in Upper Massachusetts. You can see former industrial property that in previous life it was a metals plating facility. And as a result, contamination has been left in the ground that requires cleanup before the site can be redeveloped into a more productive use. In this case, we've got some fluorinated solvents as well as metals that we're working on, and we're injecting these various amendments into groundwater to get it cleaned up. So it's pretty typical of a brownfield project that Cascade works on, and really the goal here is to get it cleaned up as cost effectively as possible to make sure that it does have attractive redevelopment potential. It's a lovely rainy day here, but it's typical where we work in all types of different conditions, whether it's cold or hot or rainy or windy. Here we are in front of the amendment. They're actually injecting into the subsurface, and this is a biosubstrate that allows bacteria to thrive and form anaerobic conditions that allow for either dechlorination of contaminants or lowering the oxidative reduction potential for treating metals. So you can see here we've got a pretty large volume of amendment to dilute and then inject into the ground. They come in 55-gallon drums. In this case, it's a 25% solution of the amendment. And so our job here today and this week is to effectively deliver all of this amendment into the subsurface. So right behind me, we've got our field technicians and our lead technology injection expert, Eric Moskal, putting together the in-hose tooling for the additional points. We're going to be manifolding up to 13 locations at a time here, and we're just pre-stringing the rods here with low pressure PVC injection hose and getting ready to put more points in the ground. Okay, well, this is actually part of our injection tool. This is a 10 slide PVC screen, 1-inch screen that we insert into the actual perforated pipe. And this is what we inject in. This is a 5-foot screen, but we can go anywhere from 1 foot to 5 foot in length. And the beauty of this is that it allows us to inject similar to an injection well by using direct push tooling. And the benefit here is that while we go to depth and while we're injecting, prevents any of the formation from coming into the injection tool and plugging it up. So we can use a PVC or we can use a stainless steel wrap screen, and we use that with all our injection tools. We're injecting into transmissive zones. Yeah, so what we have here is one of our direct push points with a free-strung inner hose tooling. And right now we are pumping at about 1 gallon per minute and at about 6 psi pressure. And so that's within the design spec. And you can see here we do have some bentonite, granular bentonite around the rods just to make sure we've got a good seal at the surface. And we're pumping away. We're at the bottom interval. This is a 2-foot screen. And we'll be, when we have the design dose in this location, we'll be pulling that up to the next 2-foot interval. On this project, we have a shallow injection interval. It's anywhere from about 3 to 10 feet. And so that's going to take very precise control of pressure and flow to not only get the distribution, but to minimize mounding or any type of short circuiting. Okay, so here we have our anaerobic water tanks. In this case, we've got two 4,500-gallon tanks, and they're poly tanks enclosed in a steel frame. They do have the ability to add mixers to them, although we don't need those for this project. But basically, we're creating our anaerobic water here, which is key to the bioaugmentation process, since the bacteria don't like oxygen very much. And we're adding a primer in here to turn the motor anaerobic. And then once it meets our spec for DO and ORP, we then pump that over where it's mixed with the substrate. And then from there we go into the injection automated manifold. So pretty basic process. In some cases, depending on the size of the project, this is a small one. We may have 5 of these tanks up to 20,000 gallons each. We're actually preparing anaerobic water to meet the total volume needs.